Okay, thank you, Grant, Aaron, and Damon. So now I'm going to take you out of PowerPoint land and into the wild world of a live demo. So I'm at qa.ocstormwatertools.org, which is our test or demonstration version of the site. Whenever Sitka stands up an application like this, we typically have two versions, the production or live version, and then the QA site that we use to demo the latest features and test out work without worrying about corrupting the actual live. Right? So I've logged into the platform here. Every user would have their own unique username and password. And what I want to do is basically just demo some of the features that Aaron and Grant talked about, but in the live web format here. So I'm logged in. I have access to a series of quick links for common tasks that might be of interest to me. And I'll start by just showing what it takes to add a BMP to the inventory. There's a number of fields that you're required to enter. Some of the fields are optional. Let's go ahead and add a hydrodynamic separator BMP. While I'm entering this form, I'm going to pop up another page so that can load while we're waiting. Get a couple of pages queued up. Must select the jurisdiction. I'm a jurisdiction manager, my role in the tool. If I were associated with a single jurisdiction, I wouldn't be able to choose from the full list. So a jurisdiction manager for the County of Orange would not need to choose their own jurisdiction because the tool would already know that. Let's go ahead and make a full trash capture BMP so we can show how this BMP might be utilized in the trash module. After entering some of the required fields, I can choose the location. I can do that by clicking on the map. If I happen to be in the field performing this on a tablet, I could use my device's GPS to set the BMP to my current location as measured by the GPS. I'm going to cheat and just copy in a particular lat long that I want to use for this demo. And with that, I've defined a new BMP in the inventory, and I'm taken to the BMP Detail Page, where I can see the basic information that I added on the Add a BMP page. I have the opportunity to associate any number of images of this BMP to help folks in the field understand that they are looking at the right asset. I can revise the location. I can add a delineation to this BMP, and I'll hop in there in just a moment. And I have the opportunity to set a number of attributes that are necessary for the modeling module that we're currently building, or to better understand the types of data that should be collected during field observations. I have the ability to launch a new field visit, define the funding sources for a BMP, and override any of the default benchmark or threshold observations that Aaron talked about. So first thing I'll do is I'll go ahead and add a delineation to this BMP, which is going to take me to a new page, the delineation workflow. So in the delineation workflow, I have a number of options on how I'd like to delineate this BMP. I can start by selecting the Edit button to edit the delineation. The first thing I have to do is determine whether this is a BMP that's collecting surface flow only, or if it is a BMP that receives an in-system in the MS4 within a pipe that collects both pipe flow and surface flow. For what we're calling a centralized or a BMP that collects that pipe flow, I have an opportunity to automatically delineate based on the regional subbasins. This is a pre-existing layer that has been maintained by OC Survey that maintains kind of our understanding of the large quarter acre to acre plus size. 40 acres. Thank you, Aaron. So these are the really large neighborhood scale delineations that a piped BMP might be gathering. And I can use that as a starting point. Alternately, I can manually delineate the BMP using a pretty handy mobile-friendly kind of drag and drop type interface to manually define a catchment. There's also an opportunity to automatically delineate the catchment based on a digital terrain model. This was a collaboration with the OC survey team where the point location of the BMP is sent via a web service to Orange County's servers, where an Esri service was developed that would walk up the physical surface of the terrain to determine the BMP location. I'm not going to demo that one because it takes a number of seconds to compute. But after I've created my delineation, it might start as provisional, and then once I've tweaked it, I can mark it as verified. This BMP now knows its drainage area and can be used to calculate trash capture benefits or pollutant load reduction benefits. I'll hop back to the BMP detail page here and now quickly demonstrate how a person in the field might start a field visit. Actually, let's go to we've created this page called the Find a BMP page, which is meant to be a really mobile-oriented way to, when you're in the field on a tablet and ready to do an inspection, find the nearby BMPs. So if I were, I'm sitting here in Portland and there aren't any BMPs in the tool nearby, but if I were in Orange County and had a GPS-enabled device, I would hit Find Nearby BMPs, and it would zoom the map and find the BMPs near me. Instead, what I'll do is look for the BMP that I just entered, the demo BMP, zooms to it on the map, and I now have the opportunity to begin a field visit. In Orange County, they're interested in tracking whether it's a dry weather, wet weather, or post-storm assessment. That's a requirement of the permits. In the field visit workflow, I can choose to review the inventory data that I added through the desktop, or skip right into the assessment, later provide the maintenance and post-maintenance assessments. Hopping in here, here are the various observations that are required for this BMP, as Aaron described. The pass-fail observations all need to pass in order for this BMP to be considered functional. And then there's an opportunity to enter how much sediment has accumulated, which is the, as Aaron called it, the analog or more quantitative assessment. Okay, next I'll just hop over really quick to take a look at the trash module. After adding this BMP and performing an assessment, I don't think I queued up the trash module yet. Let's go ahead and do that. And I'll just show this really quick because it's really challenging during these demos. I would love to have an hour to walk through this with all of you in person, but I'm trying to honor the time and agenda. It's quite painful, to be honest, to move through this quickly. So this is the trash module. In the tool, through this top-level menu, we can hop around through the various menus, the various modules that Aaron described. Within the trash module, I'll go ahead and select the city of Tustin, who has been kind of spearheading the use of the trash module to show the various trash capture devices that have been installed and delineated. The priority land uses and alternate land uses are shown according to their trash capture, and we could see for a device that has, for an area that has a full trash capture device, you can actually find the BMP that is providing that trash capture benefit and click this link to go in and see some details as we saw previously. There's also the ability to get quantitative and understand actually how many gallons per acre per year of trash are being removed in these various locations and how that trash capture corresponds to the total target load reduction. And we can see the city of Tustin is doing very well here as they've got 12,000 gallons per acre per year captured via full trash capture devices towards their target of 14,000. So this is intended to be a live dynamic view that the jurisdictional managers and perhaps one day the regulators could log in and directly see and understand how their jurisdictions are making progress, and this can be updated in real time as the assessments are performed. I think in the interest of time, I'm not going to demonstrate the online visual trash assessment workflow. That's kind of similar to the maintenance and assessment workflow that we demonstrated earlier. But if anyone who's participating in the webinar today is interested in a deeper dive, we'd love to have you reach out and we can take kind of a more leisurely walkthrough of some of the features in the tool.
John, there was one question. This kind of came in, I think, when Aaron was still talking, so maybe one of you can decide how you like to answer it, but how can this module help quantify trash down to the required NPDES discharge limit to ensure compliance?
So it provides I would say it provides two different methods for folks to track their progress. One simple track one method is to provide full trash capture type devices for all of your priority land use areas, or as you get into land substitution, there's an option for that within the regulations. And so it can provide a simple area-based accounting of which areas, I think they showed up as purple and green on the previous map that John showed, are fully addressed and which ones aren't, and start to be able to evaluate if there are areas that are priority but you can't address with full trash capture. Can you substitute in some alternate land uses that are being full trash captured? So that's one way it can get there. The other way is via load-based methods that John was just showing. So we can establish a trash generation rate for land uses. We can say what are the BMPs out there getting versus what would be required if you got to full trash capture equivalent for all of your priority land uses. And so building up what am I achieving versus what that target load reduction is would be another method that the trash amendments provide to demonstrate compliance. And then finally, someone in track 2 could be able to use the OVTA workflows to be able to show that source controls and other non-structural methods, or a combination of source controls and structural methods, are achieving the full trash capture equivalents for the priority land uses. So there's it's supposed to support different pathways for folks to build up their inventory and demonstrate their progress.
Thank you.
Thank you, Aaron.